We're going to talk more about quadratics, and so we're going to talk about how to graph using factored form. So factored form is this y equals a times x minus r times x minus s. So the quadratic has already been given to us in factored form. The a still does the same a as we saw in the other version, ax squared plus bx plus c. It's going to determine whether the parabola opens up or down and whether it's skinnier or wider than a y equals x squared. We're still interested in the same parts of our graph, that is the vertex, y-intercept, symmetric point, x-intercepts, and axis of symmetry. The difference is we'll find those in a slightly different order because we'll try to get the easiest stuff first. That is, we'll get the low-hanging fruit first. And if it's given to us in factored form, the easiest thing to do is going to be to find the x-intercepts. So again, they're going to come from the x plus 1 and the negative 2. So our x-intercepts are going to be negative 1, 0, and positive 2, 0. So we'll start with those. Then I think the axis of symmetry is actually going to be the next easiest thing to find. So we want to go halfway in between those x-intercepts. So this is a distance of 1, 2, 3. Half of that is 3 halves. So if I go 1 1/2, then the axis of symmetry, that vertical line that's going to split this parabola in the middle, is going to be at x equals positive 1/2. Now that also is going to give us the x-coordinate of our vertex. So the vertex has to lie on the axis of symmetry. So if I plug in the 1/2, and I'm going to plug it right in to that version there, then we're going to get y is going to be 2 times 1/2 plus 1 times 1/2 minus 2. So that's going to be 2 times 1 is 2 halves plus 1/2 is 3 halves, and 1/2 minus 4 halves is a negative 3 halves. If you're not opposed to canceling, we can cancel one of those 2's, and then top times top, bottom times bottom is going to be negative 9 halves. So that is going to make our vertex have y-coordinate negative 5 halves or negative 4 1/2. So that's going to put us at 1, 2, 3, 4, 5, halfway in between 4 and 5 is going to be our vertex, which is that 1/2 and either negative 9 halves or negative 4 1/2 or negative 4.5. Now we can find the y-intercept. So if we plug in to get the y-intercept, we do as we usually do. We're going to plug in 0 for the x's. So we're going to get 0 plus 1 and 0 minus 2. So that's going to be 2 times 1 times negative 2, which is negative 4. So our y-intercept is going to be 0, negative 4. 1, 2, 3, 4 right there. So there's 0, negative 4, and then the symmetric point, we're going to use the symmetry that is on the other side of the axis of symmetry from the y-intercept. A half on the other side is going to be at 1, negative 4. And then we can draw our parabola through those 5 points that we have found. Let's try it again here with the green parabola, also given to us in factored form. So if you want to pause it and try it on your own first, pause the video and try this on your own, you're welcome to. I'm going to set it equal to 0 again and see that negative 3 and negative 1 are going to be the x-intercepts. So there's negative 1, 0, and there's negative 3, 0. We're going to look for halfway in between there for our axis of symmetry. Yeah, I thought I'd forgotten to label the axis of symmetry on the other one, but we did. So halfway in between negative 3 and negative 1 is going to be this vertical line at x equals negative 2. So that is our axis of symmetry. On that axis of symmetry will be our vertex, so we can plug in the -2 for x and see what we get for y. So it's going to be a -1/2 times 1 times -1. That looks like +1/2. So that makes our vertex have x coordinate -2 and y coordinate 1/2. So if there's 1, then 1/2 is going to be halfway in between, and we'll label that -2, 1/2. To find the y-intercept, whoops, it's a left-hander touching the screen here. I'm going to plug in 0 for the x, so y will be -1/2, and then 0 plus 3, 0 plus 1, and so that's going to be -1/2 times 3 times 1, so that looks like -3/2. So our y-intercept is going to be 0, -3/2. I'm going to put that halfway between -1 and -2, and you can label it either as a -3/2 or a -1/2. Using the symmetry of the parabola, since we are 2 to the right, the y-intercept is 2 to the right of the axis of symmetry, there will be another point that's 2 to the left. That's going to have coordinates -4 and also -1/2. That's what we're calling our symmetric point, and we can connect those and get our parabola. Okay, I'm going to go to a new screen here, do different kinds of problems that we can using this idea. So we're going to find an equation of the quadratic function and then I'm going to give you some various characteristics. So first I'm going to say we have a y-intercept of 0, -3, and x-intercepts that are -3, 0, and +1, 0. So the idea here is because we have x-intercepts, this is going to suggest our factored form of a parabola. So if we do that, we know a value for r and a value for s. So to start with, our equation is going to look like y equals a times x minus -3 will be x plus 3, and then x minus s will be x minus 1. Now we still need to figure out what the a is, and that's where our y-intercept comes in. That's a value for x and y that will make this be a true statement. So I'm going to plug the -3 in for the y and 0 in for both of the x's, and that will tell us that, let's see, 3 times -1, that -3a is equal to -3, therefore a is 1, and so our equation is going to be y equals 1 times x plus 3 times x minus 1. Okay, let's do a slightly different kind of question here. This time I'm going to say the y-intercept is going to be 0, -4, and this time I'm going to tell you that it only has one x-intercept, and that is going to be at 2, 0. Well, a parabola, if you think about it, no matter how you draw a parabola, it's going to, whether it goes up or whether it goes down, if it has one x-intercept, that means what must be happening is that our parabola must be just touching the x-axis in one place. So either it's going to be tangent to the x-axis as it opens up, or tangent to the x-axis as it opens down. Either way, what that means is that our r and s are really the same value. So our starting equation is going to be a times, and it's going to be x minus 2 squared. Then we can plug in what we know from the y-intercept. So negative 4 will be a times 0 minus 2 squared. And so negative 4 will be, negative 2 squared is 4a, and so the a will be negative 1, which is going to make our equation of our parabola be a negative quantity x plus 4 squared. So one more kind of problem here. So this time we will say that the zeros are going to be, what do I want? 4, 0, 4, 0, and negative 3, 0. And this time we know that it contains the point negative 2, 1. Okay, so again, because we have x-intercepts, we're going to use as our starting structure, our starting formula, is going to be the factored form of a parabola. And we know that the 4 and the negative 3 are the r and the s, so this becomes y equals a times x minus 4 and x plus 3. This time we don't have the y-intercept, but we do have a point, so that's a value of x and y that will make this a true statement. So we'll plug in the 1 where the y is. We'll try to figure out what the a is, and we're going to plug in negative 2 where the x is. And so that's going to look like that. So negative 2 minus 4 is a negative 6, and negative 2 plus 3 is 1. So we have 1 equals negative 6a, so a will be negative 1/6. And that will make, whoops, it's my left-handedness coming into play there. I'm touching the wrong part of the screen. So see if I can do this gently. Y equals negative 1/6 times x minus 4 and then x plus 3. Okay, I'm going to do a new screen and we'll do a couple different kinds of problems here. So can we first of all solve this square root? This is kind of old stuff. See if you remember this from your Algebra 2 days. Can we solve that one? And can we solve 2 over x minus 2 plus 1 equal to 5? So the first one, we have the radical by itself on both sides of on one side of the equal sign, so we can get rid of that radical if we square both sides. And then we can add the 3 to get 52. Now you should, when you square both sides, check your solution, because it's possible to introduce what are called extraneous solutions. That is, you could get something that's not really a solution to the original. But in this case, we're going to get the square root of 49, and that's the non-negative square root of 49, which does work. So we can have confidence in our answer. In a similar fashion here, we can first subtract the 1 to the other side, getting 4. Now there's several ways of conceptualizing it. One way is to multiply through and clear the denominator. Alternatively, you could think of this as a proportion, fraction equal to fraction, and cross multiply and set those products equal to each other. A third way is you could even take the reciprocal of both sides and then multiply through by the 2 or the 4. Let's just go with the green one because we did that first. These then, when you multiply through, the x minus 2's will cancel here, and you'll just get 2 on the left side. On the right side, there's nothing to cancel that x minus 2, so it's going to multiply the 4. We can then distribute and then add the 8 to the other side, and then we can divide by the 4 and reduce, and either leave it as 5/2 or 2.5 or 2.5, whatever you like. Now, the only thing we have to watch out for here is that our answer does not make us have a 0 in the denominator of the original, but that's not going to happen, so we can have confidence in that solution. Okay, here's a different kind of quadratic. Different kind of quadratic problem. These are pretty tricky. So first, can we solve x minus the square root of x minus 6 equals 0. Well, that sure doesn't look quadratic because you don't see any x squareds in there. But if you notice, I mean, you could, I don't know if this helps or not, if you said y was square root of x, then x would be the square root of x squared or y squared, and you could make it into this, which then does factor into y minus 3, y plus 2, and so you would get y equals 3 or y equals negative 2. Then we could go back to our plug in square root of x for the y and say square root of x equals 3 or square root of x equals negative 2. Now we're okay here because we can square both sides and get x equals 9. You got to be careful here because remember a square root can't be equal to a negative. So that is actually not going to give us any meaningful solution, and 9 is our only good solution. Whew, that's tricky. Here's another one that's, we would say, in quadratic form. So I'm going to say x to the fourth plus 2x squared minus 3 equals 0. So if you want to use that same strategy, and you don't have to, you could say, well, if we thought of y as being x squared, then x to the fourth is going to be x squared squared, and then it could look like y squared plus 2y minus 3, which does factor nicely into y plus 3, y minus 1, I believe. And that would tell us that y is negative 3 or y is positive 1. If we went back to our x squareds, we would get x squared equals negative 3 or x squared equals 1. Now we want all possible solutions, but we can see we're going to have an issue here because we don't know anything about imaginaries. We're using only real numbers, so there is no number squared that's going to be negative 3. Here we want all possible solutions, so we want both the positive and the negative square root of 1. So in fact, we are going to get here 2 different solutions. Wow. All right, see if that helps you with homework number 17.